The laws of physics are a death warrant to all intelligent life.
The universe is not only stranger than we have imagined, it's perhaps stranger than we can imagine.
We have a pace of life that's based on really the energy available to us now.
The best example I can give is when you walk around and say, oh, there's a nice puffy cloud. You don't stare at it for an hour, you just notice it. If you do a time lapse of the cloud, especially cumulus clouds, they are roiling, gurgling, boiling places of condensed water vapor. They're alive. Yet when you walk down the street, you think it's just sitting there peaceful and calm, if it's just a simple cloud. Imagine watching species of life rise up, the dinosaurs, and then an asteroid comes, they go extinct, essentially overnight on the fossil record. That's a whole other way to see the world.
Your sense of time could change, right? So right now, a few minutes may seem like a lot, but in such a universe, you could have a living system where if it had a thought every 10 trillion years, that would seem normal.
If you think about how long in human time, Earth days, if you will, it took us to learn how to farm and hunt and evolve into the beings that we are, it took a long time. In comparison to the universe, it took, I think, proportionately a second, which speaks volumes about how big we are in the universe and what our impact is, which is very little.
The universe seems to evolve in 5 basic stages. The first stage was the fiery Big Bang and the creation of the early stars. We're in the second stage, very early stage, the stage of star formation.
Basically, you start out with a massive gas cloud. It collapses. As you collapse, you begin to spin faster. This is like what happens when a skater draws in his or her arms. So as you spin faster, in the plane of that spinning, the material can't fall in because the centrifugal forces prevent that.
By looking at distant supernovae, exploding stars, we can tell how far away they are, and then we can measure how fast they're moving by looking at something called their redshift. And if we see how fast they're moving as a function of their distance, we can measure the expansion rate of the universe. And it was discovered, to most people's surprise, that the universe is accelerating. Early on in the history of the universe, when the universe was mostly matter, because matter produces attractive gravity, the expansion was slowing down. It was slowing down with time. Until about 5 billion years ago, when it turns out the density of matter, which was dropping, fell below the energy density of empty space, and that repulsive energy started taking over, and then the universe has been accelerating ever since.
Something is making stuff move that is not anything we have ever touched.
What general relativity tells us is that not just matter gravitates, but energy gravitates. Any kind of energy you have produces a gravitational effect. There's one kind of energy that produces repulsive gravity, and that's the energy of nothing. If you put energy in empty space, then that energy will be gravitationally repulsive.
There is no known objects accounting for most of the effective gravity in the universe.
In order to have a flat universe, you have to have enough energy to make it flat. We also now know there's only 30% of the amount of energy and matter to make it flat. It turns out there's 70% of the energy of the universe resides in empty space. And we have no idea why it's there. Not only are we not living anywhere special, we're not made of anything special. You get rid of you and me and the cameras and the room and the stars and galaxies and everything you can see, and the universe is largely the same. We're just a 1% of pollution in a universe filled with dark matter and dark energy.
But on a large scale of things, life and star formation is just the very first two stages. Then we go into a much larger stage where the stars begin to die.
Stars explode about once per 100 years per galaxy.
Once stars run out of fuel, they collapse in on themselves. It's the amount of mass that decides what happens next. The most massive stars detonate as supernovae or collapse into black holes. If they're less massive, like our sun, they blast away their outer layers and then slowly cool down as white dwarfs.
Red dwarf stars begin to dominate the universe, then black holes. All of a sudden, all the stars are gone in the future. They're nothing but dead neutron stars. We have black holes that are dying embers of these gigantic objects that once flared up in the universe.
A star that used to be more than 1 million kilometers wide is now less than 20 kilometers across. Gravity overwhelms the atomic bonds of matter in a neutron star, crushing protons and electrons together into neutrons. They just don't have enough mass to become a black hole. These medium mass objects end their lives as neutron stars.
Imagine two black holes that have lived a long life together. Maybe they started as stars and collapsed to two black holes, each one 10 times the mass of the sun. Curves so strong that space would rain down into them. Space itself would curve like a waterfall flowing down the throat of a hole. And even light could not escape this current. Light would be dragged down the hole as everything else would be, and all that would be left would be a shadow. They can be spinning hundreds of times a second. At the end of their lives, they're going around each other very near the speed of light. So they're crossing thousands of kilometers in a fraction of a second. And as they do so, they not only curve space, but they leave behind in their wake a ringing of space, an actual wave on space-time. Space squeezes and stretches as it emanates out from these black holes banging on the universe. Imagine 1 billion years ago, two black holes collided. That song has been ringing through space for all that time. We weren't even here. You know? It gets closer and closer. 40,000 years ago, we're still doing cave paintings. It's like, hurry, build your instruments. It's getting closer and closer, and in 20, whatever year it will be when our detectors are finally at advanced sensitivity, we'll build them, we'll turn on the machines, and bang, we'll catch it. The first song from space.
It turns out empty space isn't so empty. Once we combine quantum mechanics and relativity, empty space is a boiling, bubbling brew of virtual particles that pop into existence and out of existence in a time so short that you can't see them.
the particles, or these virtual particles, will create in such a way where one of them, either the particle or the antiparticle, will actually fall into the black hole because it just can't escape the gravitational pull. The other particle will have a chance to escape and will actually start sort of flying away from the black hole. And if by any chance at the same time another pair of particles and antiparticles does the opposite, and then these two objects collide outside of the black hole, they will then, from being virtual particles, will actually turn into real 2 photons of energy. So in other words, these virtual particle-antiparticles will turn into real photons. They will emit some energy, but the way that our universe works is that you can't just create energy out of nothing. As a matter of fact, energy and mass are related. We need to actually be sucking this energy out of somewhere. And well, guess where it's coming from? It's coming from the black hole itself.
Even beyond that, atoms themselves begin to disintegrate. The proton, which is the bedrock of our existence, everything we see and touch is made out of protons, they begin to disintegrate.
Is it possible that our universe is just a plume off of some greater history? Or is it possible that we're just a branch off of a multiverse, each branch with its own Big Bang in its past? Maybe some of them with black holes playing drums, maybe some without, maybe some with sentient life, and maybe some without. Not in our past, not in our future, but somehow fundamentally connected to us.
Some people have looked for alternative cosmologies. There is a theory called the Big Splat theory, where our universe is a membrane, this gigantic beach ball, which collides with another beach ball. And the collision could be periodic, and each collision creates a Big Bang of sorts.
Every trillion years or so.
Right. So in that universe, perhaps we can start all over again, but it does mean there's going to be a fiery big crunch where everything we see around us will be in flames.
There's a speculative alternative called the Big Rip. The idea here is that the cosmic propulsion gets bigger and bigger and eventually accelerates the universe more and more to the extent that things our size get torn apart by the cosmic propulsion overwhelming the forces of chemistry that hold us together.
We think there's a lot of something out there, but that's because we're enslaved by our desires. If we let our desires kind of melt away, we'll see the world for what it truly is, a vacuity, nothingness, and we'll slip into this happy state of nirvana, which has been defined as having just enough life to enjoy being dead.
It turns out that there are fundamental constraints on life, and therefore intelligence, in the very long term.
Life in general is extremely rare. We are meaningful by existing. By what we've done and what we've explored, I think it is incredible compared to any other being that has, a squirrel finding a nut and burying it for the winter. I think we've done a lot more than just that. With comparison to the universe, it's extremely hard to feel like you are somewhere and worth something with such a huge, vast amount of space around you. So in conclusion, meaningful is kind of arbitrary.